Hello and welcome to the Chapter 1 podcast on Section 6. Dimensional analysis is something we're going to talk about today. So dimensional analysis is basically an aid in problem solving, and basically we're going to use units as a way to help us do our calculations. Now, units we're going to treat as if they were algebraic in the sense that they can be canceled if you see them in a fraction above and below. Okay, so for instance, if I have x over x, most of you guys know that x over x would cancel, the x's cancel into 1, right? We're going to do the same thing, but we're going to cancel out units, so inches over inches, for instance. What's nice about this is that it helps us kind of organize what we're going to multiply and divide by, and also helps us make sure that we have the proper units in our final answer, because if we don't end up with the units that we're looking for based on what the question is asking us, then then we know we did something incorrectly. It's also very systematic and something we're going to be using a lot in the beginning part of this chemistry course. What we're going to be primarily using are ratios and expressing conversion factors in terms of fractions. So these are ways to kind of represent equalities between units of measure. So for instance, if I have 2.54 centimeters equals 1 inch, I can use it in dimensional analysis in either one of two ways. I can make 2.54 centimeters over 1 inch or the reciprocal, and it'll all depend on what unit I'm trying to cancel out. Unit cancellation, basically the way we're going to do that is we're going to examine what the given units are and what the units of the final answer are supposed to be, and then we have to choose conversion factors or find a source of ratios that we can use to do our problem. And then what we do is we will take the conversion factor and set it up in a fraction in such a way that units cancel out, leaving us with what we want or get us on our way towards what we want to find. Sometimes we might need to use more than one conversion factor in order to get the answer we want. So for instance, here are two flow charts. So for instance, if I want to go from pounds to grams, I need to know how many grams there are in a pound. So notice how I put pounds on the bottom, because if I have a given, I'm multiplying the given, which has pounds over 1, times this. So I end up with pounds in the numerator and the denominator, which would cancel out, leave me with grams. In this other example, we're going from meters to inches. So I need to know how many centimeters there are in a meter, which is this conversion factor here. This would cancel out meters. If we stopped here, our final answer would be in centimeters, but we don't want centimeters, we want inches. So now we need a conversion factor relating inches to centimeters. Same thing with volume, but what you have to keep in mind is instead of these are usually cube numbers when we're dealing with volume. So you can use the same linear inequalities, you just have to cube the numbers that goes along with it. Okay, so if I want to go from cubic inches to grams, I can still use 2.54 centimeters per inch, but because this is cubed, I not only cube the units, I have to cube the number as part of the equality as well. And then this is part of what we can use to get to grams using the density of gold. Okay, and then here on the bottom, this is another example. So we have inches. This is the cube part of that, if we cube this. So how about some samples that can help us along? Let's say we want to know how many kilometers there are in 500.0 miles. We start with our given over 1, our 500.0 miles. I know I want to end up in kilometers. I don't know how many kilometers there are in a mile, but I know how many feet there are in a mile. I know that there are 5,280 feet in a mile roughly. Notice I have miles in the numerator and the denominator, so this is what I'm talking about in terms of canceling out. Now, if I stop right here, my final answer would be in feet, but I want kilometers. So I know that there are 12 inches in a foot, and again, feet are on top and bottom of this giant fraction, so that cancels out. I also know that there are 2.54 centimeters in an inch. So inches cancels out because you have inches above and below. Centimeters cancel out because I know for every 1 meter, that's 100 centimeters. And then I know that for every kilometer, that's 1,000 meters based upon our prefixes and our SI units. Notice how meters over meters, centimeters over centimeters, so on. But the only one that you don't see on the bottom is kilometers. So kilometers, since it's my final unit, is what the unit of my final answer will be. Notice how this is exactly what I want. The unrounded answer is this. Now remember, when you're rounding figures, we base it on the given. All these other fractions are equalities, so technically they have unlimited numbers of significant figures. So because 500 has 4 significant figures, our final answer has to be rounded to 4 significant figures as well. This is actually problem 2. But let's say we're going to do the cube. If I have 5 cubic feet, how many cubic meters is that? Or yeah. Oops, I made a typo. So let's pretend that's in. Scratch that out. So we start again with our given over 1. We know that there are 12 inches in a foot, but remember this is cubic feet, so I have to actually cube the number to 12 as well as the inches to get the cubic unit. And I know that there are 2.54 centimeters in an inch, so that 2.54 gets cubed as well. And the same thing for 100 centimeters in a cubic meter, leaving us with 0.14 centimeters. This has I rounded this to 2 significant figures because 5.0 only has 2 significant figures in it. And in the last one, here's an example of where we have 2 numbers here. So you kind of need to be creative in terms of what it is we want to do. I want to know the mass in grams of this amount of benzene. Now, I know a quart is a unit of volume, and I know the density of benzene is in grams over milliliters, which is a unit of volume as well. So what I want to do is I want to cancel out milliliters to end up with grams, right? That means I'm going to have to convert quarts to milliliters before I can multiply it times the density. So I start with 1.00 over 1, and I looked up that there is 946.36 milliliters in a quart. Quarts and quarts cancels. And now I can multiply this times the density of benzene to get the mass. So milliliters over milliliters cancels out, leaving me with grams. So we have 831 grams as our final answer. This has 3 significant figures because our density has 3 sig figs as well as the 1.00. So our final answer should have the same number of significant figures. We're going to practice this in class over the next period or so. These are examples I hope that make sense and something you can look back onto later on. And until next time.